This video is for section 2.6, limits involving trig. And in this video, we're going to go through an example of a problem that has tangent functions in it. Alright, so this problem is actually not found in your book. Here's some free bonus material for you. But it says the limit as x approaches 0 of tangent 6x over tangent 5x. Okay, remember, first step when solving limits algebraically is always to try direct substitution and see what happens. Alright, so for direct substitution, I plug in 0 wherever I see an x. On the top, I get tangent of 0. Tangent of 0 is just 0 over 1, which becomes 0. On the bottom, I get tangent of 0 again. So I get 0 over 0. Probably not surprised, this is an indeterminate form. That means we need to do more work. And remember, when we're dealing with trig functions, our first two steps are always, number one, make sure that the entire function is rewritten in terms of just sine and cosine. And number two, try to get that function to match one of our identities here. Alright, so in this example, it's not written in terms of sine or cosine yet, so that's going to be the first thing that we do. So I have tangent of 6x over tangent of 5x. Remember, tangent is just sine over cosine. So I'm going to rewrite both of these tangents in terms of sine and cosine. So now they become sine of 6x over cosine 6x, all that over sine of 5x over cosine 5x. Okay, now I have this. It looks lovely. Just kidding, it looks really terrible. I have a fraction within a fraction. That's really gross. It's hard to look at. So I'm going to rewrite this and try to get it into just one fraction just so that it's easier to look at. So I'm going to use some different colors here. On the top, I have sine 6x over cosine 6x. And that's being divided by this entire fraction down here. So it's being divided by sine of 5x over cosine of 5x. Okay, but remember, whenever you're dividing by fractions, you're really just multiplying by the reciprocal. So I'm going to flip this over, move over here, and I have sine of 6x over cosine 6x times cosine 5x over sine 5x. And now I'm just going to multiply straight across, and now I'm just left with one fraction, which is much nicer to look at. Now I have sine of 6x times cosine of 5x over, I'm going to write my signs together, sine 5x cosine 6x. All right, that was just step one. Now we have our function rewritten in terms of sine and cosine. Now we move on to step two, which is trying to make this function look more like one of these functions. Okay, so looking at what I have here, my cosines, they don't really match my cosine identity at all. So I'm going to first focus with my sine functions and try to make this match my sine identity. And if you remember, the sine identity said the limit as x approaches 0 of sine something over that same something equals 1. Okay, so I'm going to separate this fraction out so it's a little bit easier to see. I have sine 6x over 1 times 1 over sine 5x. And I'm just going to leave my cosines the way they were. Times cosine 5x over cosine 6x. All right, so looking at my sine functions, oops, this should be an arrow. Looking at my sine functions, I need each of these to match my sine identity. So my first one, sine 6x over 1, well, what's different between this and my sine identity is the bottom isn't matching my angle on the inside of the sine function. So I need to multiply this by 6x over 6x. Remember, whatever you do to the bottom, you have to do to the top. And same over here, what's missing in this fraction, to make it match my sine identity, I need a 5x in the top. So I'm going to multiply everything by 5x over 5x. All right, let's move down over here. See what happens when we multiply things out. Over here, I get sine of 6x over, I moved my 6x over here. But remember, there's still a 6x in the numerator. So I'm going to write that right here just to keep track of it. Okay, same thing here. Move my 5x over. So now I have 5x over sine 5x. But remember, I still have this 5x in the denominator. So times 1 over 5x. And lastly, I still have my cosines over here. Haven't really done anything with them. Cosine 5x over cosine 6x. Alrighty. And remember, the problem was initially asking us the limit as x approaches 0 of all of this. Okay, at this point, now I have things that match my sine identity. So I'm going to go ahead and cross these out and put in whatever they equal. So my sign identity says if I have sine something over something and x is approaching 0, that limit is just 1. So whenever I see that identity, cross it out, I'm going to put 1. Sine 6x over 6x matches identity, that's 1. This matches the identity, that's going to be 1 too. All right, let's see what we're left with. So now we have the limit as x approaches 0 of I have a 6x here times of 1 over 5x times my cosine 5x over cosine 6x. I'm going to go ahead and cancel out these x's. So now I just have 6 over 5 times cosine 5x cosine 6x. All right, that was a lot of simplifying. But now it looks like we're about done. So from here, we're going to try direct substitution again and see what happens. Hopefully we get a valid answer this time. All right, so I plug in 0 wherever I see an x. That leaves me with 6 over 5 is still there. Cosine of 5 times 0, that'll be cosine of 0. Remember, cosine of 0 is just 1 over cosine of 0, again, is 1. So this leaves me with 6 over 5 times 1 over 1, or just 6 over 5. So that means that the limit as x approaches 0 of my original function, tan 6x over tan 5x, was equal to just 6 over 5. That was a lot of work, but it really wasn't too hard. It's just a lot of algebra going on. You had to keep track of a lot of different fractions. But brief recap, so we started with a function that had tangent in it. So our first step after direct substitution was to rewrite the tangent in terms of sine and cosine. And then from there, I had the sine and cosine match one of my identities. And then once I got my sine functions to match my sine identity, I crossed it out because it just equals 1. And from there, I just saw what I was left with. And what I was left with just multiplied out to be 6 over 5 times 1, which was a valid answer, and that's the answer to my limit.